A star is going dark, and no one alive can tell you why. Not slowly like a dying sun, not on schedule, like a planet passing in front of it. It just drops, sometimes by a fifth of its light, in days. Then it returns, then it drops again. And nothing we know should be able to do that. 1,470 light-years from Earth, in the constellation Cygnus, there is a star cataloged as KIC 8462852. Most people call it Tabby's star, after the astronomer who first noticed something was wrong. From the outside, it looks ordinary, a little hotter than our sun, a little larger, burning a steady white gold. It should be one of the most boring objects in the sky. It is not. In 2009, NASA launched the Kepler telescope to stare at a single patch of sky for years, watching for the faint dimming that happens when a planet crosses in front of its star. That dimming is tiny, a fraction of a percent, regular like clockwork, repeating every time the planet completes an orbit. Kepler watched 150,000 stars this way, and buried in that ocean of data, one star did something the others did not. The dips were enormous. Some erased 15, even 20% of the star's light at once. A planet the size of Jupiter would block barely 1%. To swallow a fifth of a star, you would need an object roughly the width of the star itself. Nothing natural orbits like that, and the timing made it worse. The dips were not regular. They came without rhythm, without warning, some lasting days, others stretching for weeks. The shapes of the dips were wrong too. Not the clean, symmetrical curve of a passing sphere, but jagged, lopsided things, as if something with edges and structure were drifting across the light. When the data was first published, the scientists were careful. They listed every ordinary explanation they could think of, and one by one, they crossed them out. A planet, far too small. Instrument error, the signal was clean, confirmed, real. A close companion star pulling material loose? Possible, but the evidence didn't fit. They were left with a description, not an answer. A swarm. Something broken into pieces, a cloud of fragments orbiting the star in an uneven, tumbling mass. The leading idea became a shattered field of comets, an enormous family of icy bodies disturbed from the cold outer edge of the system, falling inward, spreading into a veil of dust that drifted between us and the star. It was the calmest explanation available, and it still required hundreds of comets, far more than we have ever seen around any star, arriving at exactly the right time for us to catch them. But there was another idea, and it refused to die quietly. Because the dips were so deep, so strangely shaped, so unlike anything in the catalog, a few scientists asked a question they knew would follow them for the rest of their careers. What if the thing blocking the light was not natural at all? What if a civilization, far older than ours, had begun to build around its star? A vast structure, panels and rings to capture its energy, half-finished, casting irregular shadows as it turned. They did not claim it was true. They simply admitted they could not yet prove it false. And then the story deepened. Researchers went back through old photographic plates, images of the same patch of sky stretching back over a century, and they found that across 100 years, Tabby's star appeared to have faded, slowly, steadily, dimming overall, on top of its sudden plunges. A star does not simply grow dim across a human lifetime. That is not how stars are supposed to behave. The mystery had a long memory, and it had been hiding in plain sight before any telescope was built to watch it. When astronomers finally caught a fresh dip in real time, they pointed every instrument they had at it. They watched the star fade across different colors of light, and the answer they got narrowed the field, but did not close it. The star dimmed more strongly in blue light than in red. A solid object, a moon or a wall, or a megastructure, would block every color equally. It would cast a flat, neutral shadow. This shadow had a tint. That tint means dust. Fine particles, small enough to scatter blue light while letting red slip through. Whatever surrounds Tabby's star is not solid. It is a cloud. And yet that only moves the question. It does not answer it. Because we still do not know where so much dust came from, why it arrives in such uneven waves, or why the star has been quietly darkening for 100 years beneath it. The comet swarm remains the favorite, But favorite is not the same as proven. Some models say the dust could come from a single shattered planet, ground down over ages into an orbiting ruin. Others point to material the star itself may have consumed long ago, still settling, still casting its long shadow our way. The truth is that no single explanation fits every observation cleanly. There are pieces that still do not line up. Tabby's star is still up there right now, 14 centuries of distance between us. Every flicker we see left it before the fall of empires we read about in history books. We are watching the past, and even the past will not hold still for us. The light reaching your eyes tonight began its journey when the world below was a very different place, and we still cannot say what reached into that light and bent it. So the question hangs there, in the dark of Cygnus, unanswered. If a star this close, this watched, this measured can keep a secret from us for this long, what else is flickering out there in the silence, waiting, that no one has thought to look at yet?